All right, our first equation is the kinematics equation, saying that if we have something which starts at rest and then accelerates for some particular time, it will reach a distance which can be given by, so this is our distance, and our distance will be, the distance is 1/2 the acceleration times the time squared. All right. Number 1 says, a certain car has a constant acceleration. Starting from rest, it travels 10 meters in 3 seconds. How far would it have traveled in 6 seconds? So we can say that the original time was 3 seconds. The new time is 6 seconds. Clearly, the time has become twice as large. We look at our equation and we say, well, the time, though, is squared. So the right-hand side has become 4 times as large, which means the left-hand side has to be 4 times as large. And the only way to do that is to increase the distance by 4. So the distance has to become 4 times the distance, which in our problem is 4 times 10 meters, or 40 meters. All right, problem number 2. When dropped from rest from a rooftop that is 50 meters tall, a ball will take 3.2 seconds to hit the ground. How long would it take from a rooftop that was 150 meters tall? And we're reminded that objects fall with constant acceleration. So here we can see that we have taken the distance, which had been 50, and we have made it 3 times as large by making it 150. So we can see that the left-hand side has become 3 times as large, which means the right-hand side has to become 3 times as large. And the question is, what can I do over here that gives me a factor of 3? Well, I'm not allowed to change the acceleration, so I got to change t squared. So I'm looking for the idea that the effect we're looking for has to square to 3. So the effect has to be root 3, meaning that the time has to become root 3 times the original time. So we take out a calculator and we say, what is square root of 3 times 3.2 seconds? And that turns out to be just about 5.54, which, according to our sig figs and what was given to us, would be the 5.5 second answer. All right, number 3. Cars 1 and 2 have accelerations a1 and a2 respectively. Starting from rest, it takes car 2 twice as long as car 1 to travel a particular stretch of road. Which of the following is true? In this case, twice as long means twice as much time. So here we're saying that we have the same distance, but we are doubling the time. So once again, t has gone to 2t, which would tend to make this side larger by a factor of 4. But I can't make that side any larger because this side can't change. So we have to multiply this by 1/4 so as to compensate that quarter and get a factor of 1. But we can't change the half. That's silly. So it must be a has changed by 1/4. So a2 is 1/4 of a1. The other scenario was circular motion. An object of mass m traveling around a circle of radius r at a constant speed v must feel a centripetal force F given by the formula that F equals mv squared over r, or else it won't go in a circle. So we'll work with these through. All right, so number 4 says, if the object were replaced by one with a mass that is 4 times as large, traveling the same circle at the same rate, what would the new centripetal force need to be? So if we still want to go in a circle, what happens to our force? And notice we are being clear here that v squared and r are not allowed to change. So we have m going to 4m. M becomes 4m. So the right-hand side has gone up by a factor of 4, which means the left-hand side has to go up by a factor of 4, but the left-hand side is F, so F must become 4F. All right, number 5. The engineers decide it's necessary to reduce the force by a factor of 5. If the track is fixed so that R cannot be changed, and we leave the M alone, then what should they do? And we can either increase or decrease the speed, and by what factor? Well, we want to make this side 1/5 as large, which means we need to make this entire side 1/5 as large. But we can only do that by making V, we need to make V squared 1/5 as large. And we can only do that if we have 1 over root 5 inside the square. So we need to reduce the factor or decrease the speed by a factor of root 5. We need to divide it by root 5. Lastly, number 6, a car turns due to the force of friction on its tires, which is essentially constant, so F can't change. The fastest safe speed at which a particular car can round a corner of radius 50 meters is 20 meters per second. What would be the minimum safe radius for the same car if it was moving at 40 meters per second? So here we look and we say, well, this one has to be constant. We have taken V and moved it to twice V, which means V squared has become 4 times as large. It's now 4V squared. So the whole numerator is 4 times as large, which means the denominator needs to be 4 times as large as well. And 4 times the original 50 is 200.